everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about different types of charts and graphs in statistics. So when it comes to statistics, so many of the people know that statistics is a method of conducting a study about the particular topic. So by collecting, organizing, interpreting, and finally presenting the data. So statistics is mostly used by statisticians. So in order to conducting a study about the particular topic and by collecting, organizing, interpreting, and finally presenting the data. So the usage of statistics in daily life should be government agencies and then should also be used in science and medicine, psychology, education, and then different companies. So these are some of the daily usages of statistics, so many of the applications. So in government agencies, they are going to be used according to retrieving the data and how the statistics is going to be applied, and it should also be used in science and medicine as well, and then maintain education, psychology also, and then companies. So before going to what are the different types of graphs we are going to have in statistics, so very first thing is that bar graph. So bar graph is nothing but a chart that is going to be used either horizontally or vertically to show the comparisons between the categories. And so normally this bar chart will be of different types. So like single, multiple, and stack. So single means we're able to represent this bar charts either in a vertical way or horizontal way. So like this. And multiple means we're able to show a, for a single attribute. So we're going to show the multiple characteristics. So that should be multiple bar chart. And stacked bar chart means here the bar is going to be divided into different compositions. So it should be equal to the 100%. So these are the different categories of bar chart. So by looking this example, so I'm taking the colors of cars and as an example on x-axis, and then number of cars sold on y-axis. For this, I would like to know, so what are the colors of cars that is going to be sold every year. I want that should be the problem. So for that, how I'm going to represent a bar graph. So the cars which is having the blue color is going to be sold around some 400 in any year, and then white color it should be around 500, and red color it should be around 1400, like this. So this should be the way of representing the bar chart. And comes to the advantages of this bar chart, so it should be able to show the category data category in the frequency distribution, and it should also display the relative numbers or proportions of multiple categories, and which should also be categorized the large data set in visual form, and then which should also be estimate a key values at gallons, and which should be also easily understood and to widespread in use of business and then media. So these are some of the advantages. So mainly this one should be the data category of frequency distribution, and then can also be summarize the data set. So these are the main advantages of this bar chart. And comes to the disadvantages of this, it should also additional require some additional explanation is required here, and this should be easily manipulated to yield some false impressions, and then we should also be failed to reveal some key assumptions, causes, and effects and patterns. Okay, so these are some of the disadvantages of this bar graph. Okay, so for representing the bar graph, so we have to need some additional information, and then additional explanation is needed, and then should be easily manipulated by someone else, so should also be leads to some falsy impressions, and then should also reveal some of the key assumptions and causes and effects of patterns. And this is some other way of representing the bar graph. So here I'm considering the years on x-axis and then profit along the y-axis. So for this I'm going to represent the bar chart. So I'm taking years on x-axis, and then uh, number of property millions should be along the y-axis. So for the 1981 it should be $10 million profit is getting, so that should be like this. I'm going to represent it. And for 1919 it should be 12 or 11, assume it, so 11, and 10. Like this I can able to represent the bar chart. When it comes to the multiple bar chart, so this is the another way of representing. So for the single attribute, I can able to represent the multiple characteristics. Like suppose a so number of imports and exports that is going on in a year 1991, 92, 93, like this. I want to show it. So for this, I'm going to mention the two bars in a single year, like 1991. I'm going to represent. So this is for import and this is for export. So these two colors are going to be indicate this. Yellow should be the import and then green color should be export here. So like this, if I want to show, then I have to go for the multiple charts. So similarly, 1992, so number of imports and exports, and 1993 number of imports and exports. So this kind of information I can able to represent by making use of this multiple bar chart. And this is another way of representing the bar chart. What I said here is that, so I'm Germany, France, Canada, United Kingdom. I'm taking the countries and number of sales that is going on in around y-axis I'm considering, and this one is going to be considered as quadrants here. So K1 is one quadrant, should be of green color, and light green should be quadrant 2. Somewhat light green should be quadrant 3, and then quadrant 4 should be light green color. So like this, I want to represent using multiple bar charts. So in Germany, so I am going to represent what are the number of sales in quadrant 1, 2, 3, and then 4. Similarly, in another country, what are the number of sales in quadrant 1, 2, 3, and then 4, like this. And next one is subdivided bar graph. So it should be defined as to represent the data in which the total magnitude is going to be divided into different components. So normally this one is going to be used especially in representing the total number of elements in the group, and it should also be useful and also helps in identifying and comparing the difference between the components. So what is this mainly purpose of the subdivided bar graph is that, so it should mainly helpful in representing the total number of elements, and it should also be helpful in identifying comparing the difference between the components. So what should be subdivided bar graph is that, so mainly it is going to represent where the total magnitude is going to be divided into different components is the main purpose of this bar graph. So suppose I'm going to consider this. So division A, B, C, I'm considering three divisions. So in division A, what are the number of boys and girls I'm representing? In division B, so number of boys and girls, and number of boys and girls in division C. So normally I can able to represent this one through multiple bar graph. So some other better way of representing this bar graph is that multiple stacked bar chart. So that means that, so here in a single bar itself, instead of representing the two bars, in a single bar itself I can able to represent, so the percentage composition of boys and girls, and here also the percentage composition of boys and girls, like this. Okay, so this is the somewhat better way of representing the bar chart. And suppose, so expenses of family A and family B I'm considering, and what are the expenses that is going to spend for family A on food, cloth, and petrol I want to represent, and similarly and B, so what should be the expenses that should be spent on food, cloth, and then petrol I want to represent it. So like this, so this is the 100% stacked bar chart. That means where you can able to represent, and that should be equal to the 100% of this presentation. So pie chart. So pie chart is means that, so uh, it is going to be used to make use of sectors in circle, and then the angle of sector is proportional to the frequency of the data. So the pie chart is a good way of for displaying the data when you want to show how the something is going to be shared and divided. So normally the pie chart is also known as pie graph or circle graph. So make use of the sectors in the circle. So the angle is going to be proportional to the frequency of the data, and it should be a good way of displaying the data when we are going to show how the something is going to be divided. So for calculating this formula, so I'm going to calculate the angle of the sector for this. So that should be calculated as the frequency of the data divided by the total frequency, that should be multiplied by 360 degrees. So this is the equation you have to be remembered for calculating the angle of the sector here. Suppose I am considering an example like in a school there are 750 students in year 1 and 420 students in year 2 and 630 students in year 3. So where they can able to draw the circle graph in these groups. First, so for that, what I'm going to do that is for first I'm going to calculate the total number of students. So from by make use of that, I'm going to calculate the first size of the angle. So that means 750 divided by total number of students into 360. So I'm going to get 150 degrees. So this thing should be represented into percentage. So for that again I have to be divided by 150 divided by 360 into 100 so that I can able to get the 42%. And similarly for selecting the size of second angle. So the second one is that a number of students is there 40, 420 and total number of students is 800, 1800. So that should be multiplied with 360. So I'm going to get 84 degrees centigrade. So if I'm in turn multiplied by 100, so in order to get this percentage value. So like this, I'm going to get the percentage values of students. So in first year, second year, and third year. So the main advantages of this pie chart is that so it should be made proportional to the total quantity. So it represents and it should also represent a large data set in visual form, and it should be also simpler than other type of graphs, and it should also permit the visual check of reasonableness or accuracy of the calculations. So mainly this is going to be required minimal additional explanation. So which should be easily understood due to widespread use in business and the media. So the size of this circle normally should be made proportional to the total quantity, and it should also be summarized the large data set in visual form. And this one should be visually simpler than the other type of graphs. So it should also be required minimal additional explanation, and it should be easily understood due to widespread in use of business and the media here. And disadvantages is that so it does not easily reveal the exact values. So many pie charts may be needed to show changes over the time, and it should also fail to reveal the key assumptions, causes, effects, and patterns as well. And it should be easily manipulated to yield the false impressions also. So these are the some of the ways of getting the disadvantages of the pie chart. So mainly, main thing is that so it does not easily reveal the exact values. So that is the major disadvantage in pie chart. So sometimes the key assumptions also fail, and intent should also be need the changes that should be changing over the time, and should also be easily manipulated by the false impressions as well. The next one is that histogram. So what is the histogram? So histogram is nothing but the graphical representation. So it should be mainly helpful in organizing the data, and then also it can able to display the data in more user friendly environment. So normally this one is going to be used mainly in the purpose of comparing the process within a specified limits, and it should also be summarizes the large data, and it assists in decision making as well. So the histogram is the another kind of representing where you can able to represent the quantitative data, and this one mainly useful or helpful in order to organize and display the data in more user friendly environment. And mainly this one is going to be helps in comparing the process within a specified limit, and it should also the summarizes the large data, and it should also assist in decision making. So these are the some of this uses of the histogram. So let's take an example how we're going to construct the histogram. So for this, I'm going to create the class intervals. So the only difference between the histogram and bar chart is that so I'm going to represent no space between the bars, then it should be the bar chart. And if I'm not allowing space between the bars, then it should be the histogram. So there is a similar easy observation where I can able to differentiate the histogram and then bar chart. And at the same time, so this one is represented along the single variables or attributes what I can insert, and this one is going to be represented in between the interval values. So that is another difference I can able to suggest between the bar chart and the pie chart. And so here classes of information I'm going to consider is that intervals and frequencies is the number of pens here, and this should be in between uh, 20 and 30. So the frequency is 15, in between 30 and 40 it should be 20, and 40 and 50 it should be 30, and 50 and 60 it should be 20. So how can I able to represent this histogram? So in between the 20 and 30 and the frequency value is 15, so I'm consider that, and that means I can able to draw this, and without in between the interval between 30 and 40, so the value should be around 20, so I'm going to construct uh, 20 here, so without any gap between the two bars, and in between the 40 and 50 it should be around some 30, so without any gap I'm going to construct this. So like this I can able to construct the histogram. So let's take a large data set. So this is the data set I'm going to have. So for this, what I have to split the data into intervals, and then I have to identify number of the frequencies of that variable. So initially I'm going to suggest these intervals like 15, 20, 20 to 25, and 25 to 30. And finally, I'm going to count this number of frequencies in between 50 and 20, how much it is, and 20 to 25, how much it is, and 25 to 30, how much it is. Like this, I can able to segregate it. So once I can able to get the frequency data according to the intervals, so that thing I have to be considered, and I have to construct the histogram. So by plotting this 15 to 20 interval and 20 to 25 and 25 to 30 like this, so I can able to represent what should be the frequency of in between the 15 and 20, and 20 to 25 what should be the frequency, and 25 to 30 what should be the frequency, and 30 to 35 what should be the frequency. Like this I can able to represent it. And next one is the frequency polygon. So frequency polygon is also another kind of graph that should uses the lines which is going to be connect the points plotted for the frequencies and the midpoint of the classes. So normally this one where the frequencies is going to be represented by height of the points here. Okay, so the histogram is the first thing of construction. So once the histogram is constructed, based on this I can able to construct the frequency polygon. So that means that, so this is the graph, so which uses the line to connect the points plotted for the frequencies at the midpoints of the classes, and the frequencies that is going to be represented by height of the points. So in order to construct a frequency polygon, so find the number of points of each class and draw an x and y axis. So label the x-axis with the midpoint of each class, then that should be uses a suitable scale for the frequencies on the y-axis. So using the midpoints on for x-axis and the frequencies as y values, so connect the adjacent point with the line segment and draw the line back to the x-axis at the beginning and the ending of the graph. So these are the steps you have to be considered for constructing the frequency polygon. That means, so find the midpoints of each class. Okay, so by drawing the x and y axis, and then label the x-axis at the midpoint of each class, and use a suitable scale for the frequencies on the y-axis. That means, so once I constructed the histogram, so very first thing we have to find out the midpoint of each and every class. So then I have to label the x-axis what is the values, and label the y-axis what are the values. So normally the those frequencies I'm going to be considered along the y-axis, and the values I'm going to be considered, that means interval I'm going to be considered on the y-axis. So using the midpoints of x values and frequencies plot the points. So by making use of this, I can able to identify the midpoint of each and every part in between them. So once the midpoint is identified, so connect the adjacent point with the line segment. So we have to be join these midpoints with a line like this, and we have to be construct like this. So the line, draw the line back to the x-axis at the beginning and ending of the graph. So once they can able to construct this, then after that I can able to remove this bars. So finally I can able to get a curve. So this curve should be called as the frequency polygon. So these are the steps you have to be remembered for constructing this frequency polygon. So let's take an example. So frequency polygon has a 642 psychology text scores, so in the figure, and so for that each and every text score I'm going to be consider at lower limit value and upper limit value. That should be the interval I'm going to fix it out. So in between 29.5 and 39.5, so what is the value, and in between 39.5 and 49.5, so the counts are identified. Okay, so these are the frequencies of values for each and every interval. So once that thing is known, then we have to be calculate the cumulative count. So what should be this cumulative count is that, so first uh, so initial value, so the next value is going to be get by adding 0 plus 3. So and then next 13 is going to be get by adding the next frequency value with the value, so that should be 13, and this one is going to be get by adding 13 plus 53, how much, 66 is going to be get, and 16 plus 107, it should be 170. So like this I can able to get the cumulative count frequencies for constructing the frequency polygon. So let's take an example like this. So first label on the x-axis is 35. So it should be represents an interval of exceeding 29.5, and lowest test score is 46. So interval has a frequency 0. So like this we are going to be store all the values, frequency values in between the intervals, and there should be around the 147 scores in the interval that is going to be around 785. So for this, how I'm going to construct the frequency polygon. That means, so here I'm going to be construct the class intervals of 35 and 45, and so let's, it should be like this, and next 45 to 50 to 55. So how it should be comes next. So it should be the midpoint of the class interval actually, and this is the midpoint of the class interval. So once I joined all these midpoints, so I can able to get the curve normally. So these are the midpoints, and then after joining all these midpoints, I'm going to get this curve actually. So this is the way of constructing the frequency polygon. And next one is obtuse. So obtuse is nothing but this should be the under cumulative frequency polygon. So normally this the graph is going to be represent the cumulative frequencies for the classes in the frequency distribution actually. So in order to construct an obtuse, so find the cumulative frequency for each class first, and draw the x and y axis and label the x axis with the class boundaries. So label the y axis with appropriate frequency as well. So plot the frequency curve at the each upper class boundary, and starting with the first upper class boundary, so connect the adjacent point with the line segment and extend the graph to the first lower class boundary on the x-axis. So this is another kind of the graph given, so normally called as a frequency cumulative frequency polygon. So this one is going to be constructed. We need to follow some of the steps like, so first find out the cumulative frequency of each class. So previously I told so how to construct the cumulative frequencies, right? If I'm going to construct this, I can able to construct a graph what I can able to call it as the OGIV. So this OGIV is mainly particularly constructed based on this cumulative count only. So for that, so first calculate the cumulative frequency of each class, and then first draw the x and y axis and label the x axis what should be the class boundaries, and y should be the appropriate frequency. So then plot the cumulative frequency at each upper class boundary. That means, so here also I'm going to construct the histogram first. So once the histogram is constructed, then I can able to uh, draw a curve by joining all the midpoints of the bar like this. So once I jump with a smooth curve, what I can able to curve, and this thing normally what I'm able to call it as a frequency curve actually. So previous thing is frequency polygon, and this should be the cumulative frequency curve. So for this, first we have to be construct some of the procedures we have to be followed for the constructing of view. So choose the suitable class for the class of the frequencies or cumulative frequencies, and represent the class boundaries for the histogram or OQ, the midpoints of the frequency polygon as well on the x-axis, and plot the point. Then you can able to draw the bars along the lines. So these are the some of the ways of the constructing this statistical curves actually. So see the example first. So this is the example I'm going to have, like following data of people of weights in grams, kilograms I'm having. So from this, so first what I have to do is, so first of all I have to in order to get the interval, so first I have to apply the stem and leaf graph. So once I can able to get this stem and leaf graph, so I can able to decide the class interval. So among this, how to construct this stem and leaf graph is that, so the stem is nothing but leading digits, and leaf is nothing but trailing digits. So if I'm going to consider 5, so that should be the stem. So 6, this should be the stem. 7 also stem, and 8 also stem. So after 8, I'm going to have 9. So 9 should be the stem, and 10 should be the stem. So once they identify the stem, I can able to identify the trailing digits of each and every that should be treated as a leaf here. So for 5 it should be 0, and for 6 it should be 5, and 5 it should be 7 for this, and 8 it should be 0, 5, 6, 5, 6, 6, 7, 7, 7. So this and all will be the trailing digits of 8, and for 9 it should be 0 and 2, 8, and 10 it should be 5. So these are the sum of this stem and leaf construction. So once I can able to identify, so based on that I can able to segregate this weights. So 40 and 50, so how many number of people are there? In between 50 and 60, how many people are there? In between 60 and 70, how many people are there? So in between 40 and 50, so no one is there, 0, and then 50 and 60, it should be like 1, and in between 60 and 70 it should be 1, and 70 80 is also 1, and for 80 it should be 70 and 81, and 80 81 85 85 86 86, and then 87, and like this. So 1 2 3 4 5, so this should be one set. So that should be around 9 1 1 1 0, and 90 and 100 in between 90 92 3, and 100 to 110 should be 1. So this should be the frequency yet of getting this. So once the frequency is getting, so I can able to do the calculating of cumulative frequency. So 0 plus 0, so 0 plus 1, and 1 plus 1 2, so 2 plus 1 3, 3 plus 9 12, 12 plus 3 15, 15 plus 1 16. So like this I can able to calculate the cumulative frequency. So once the cumulative frequency is done, so I can able to represent this, and these are the some of the steps so I have. So very first step is that, so we have to put the data into the table. So based on this, and third step is that we have to put the frequencies by which the events is going to be covered, and so frequencies are calculated, and then finally I'm going to get the cumulative frequencies as well. So draw the graph. So based on the cumulative frequency. So in between 40 and 50. So 40 and 50, and then 60, 70, 80, and then 90, 100, and then 110. So these are the values. So if I'm going to be joined with a line, so that should be a frequency polygram. And next thing is the pictograph. So pictograph is nothing but which is going to represent the frequency of the data as the pictures or symbols, and each picture or symbol is going to be represent one or more units of the data. So that means, so instead of representing the values, I'm going to represent directly. So draw the frequency of number of cars that is going to be sold of different companies I want to show. So for that, and so instead of representing these values, I can able to represent the picture itself of the car. That means, so Ford. So how many number of cars are sold, and Toyota, how many number of cars are sold, and Renault, how many number of cars are sold. Like this, I can able to represent. So see the under example. So the number of computers sold by the company for the months January, February, January to March, and construct this pictogram for the table. So in January it should be 25, February 35, and March 20. So instead of representing the entire values, I am going to construct each diagram. Each computer is going to present 5. So that means, so totally, so 5 into 5, that should be 25. So like this, I can able to represent also simply. And if I'm going to get February, so 1, 2, 3, 4, 5, 6, 7. So 7 into 5, 35. So that means 35 are going to be sold in February. And next, March, so 20. So 20 is going to be sold in March. So instead of representing a single diagram, so if the values are going to be more, so at the time also I can able to use this to not in order to represent that. So what are the advantages of pictogram like this? Means, so it should be easy to construct and visually appeal. And then disadvantages should be they are very difficult to draw it. So since the pictures is going to be drawn, and then icons should also be consistent size and best for only 2 to 6 categories and very simplistic. So normally this should be the difficult to draw, and icons should also be consistent, and where I can able to represent uh, only this should be the best for 2 to 6 categories, and icons will also be consistent size and very simplistic. So these are the disadvantages of that. So very advantage, so it should be easy to read and visually appealing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.